All right, good day. Today we're going to talk about mutually exclusive events. Now, mutually exclusive events, when we draw a Venn diagram, they look like this. But mutually exclusive events are multiple events. Maybe not multiple. I should probably write two or more events that cannot occur at the same time. And there are a lot of things that cannot occur at the same time. So if we were talking about rolling a dice, you cannot roll a 2 and a 3 at the same time. Those two don't happen. So we can say that they are mutually exclusive. Another mutually exclusive events are it cannot rain and not rain at the same time. One has to exist, but mutually exclusive just means that both of them can't exist at the same time. So, and when we draw them in a Venn diagram, what we notice is that the sample spaces are going to be entirely disjoint. So what can we conclude? Well, the probability of A or B occurring at the same time. Now, maybe let's say this is the probability of A and this is the probability of B. The probability of A or B is going to be the probability of A occurring or the probability of B occurring. That's what happens when there is mutually exclusive events. Now, non-mutually exclusive events are two events A and B that are not mutually exclusive, can have some common outcomes. I don't know. I'm going to say we can get back to rolling a dice again, but maybe I'm going to take a look at cards. If I say, what is the probability of flipping an ace or a red card? Well, there's a probability of an ace, and there's a probability of flipping a red card, but there's also a probability of flipping there are some outcomes that are both red and an ace. So we have to treat this probability a little bit different. So we can say the probability of A or B occurring, well, it is going to be the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring. Now, simply, why do we have to subtract out this second term? Well, in fact, if you highlight A and then you highlight B, what ends up happening is you highlighting this middle area here twice. So you have to subtract once just to make sure you're only counting it once. All right, so mutually exclusive, there are two events that can't happen at the same time. Non-mutually exclusive events that are two events that may happen at the same time. It can be sunny and rainy at the same time. Very rare, but they're not mutually exclusive. All right. So hopefully we're going to do some examples that will clarify some stuff. Tim has a set of cards that are numbered 1 through 15. He randomly draws a card. Now let's consider the following events. Event A is the probability of flipping a card that is a multiple of 2. Event B is drawing a card that is multiple of 3. So I'm just going to help me understand this. A is a multiple of 2, and all the cards are numbered 1 through 15. So 2, 4, 6, 8, 10, 12, 14. So those are all the cards that are in event A. And event B are going to be all the cards that are multiples of 3. So 3, 6, 9, 12. And instantly, what we're able to see is that there are some common elements. So namely, 6 are both multiples of 3 and 2. Same with 12, right? So are these mutually exclusive? Definitely not. No. Because they share outcomes of 6 and 12. In other words, event A and B can happen at the same time. What is the probability of drawing a number card that is a multiple of 2 or 3? So since these are not mutually exclusive, so the probability of A or B is simply going to be the probability that A occurs plus the probability of B occurs. Now, minus, since they're not mutually exclusive, minus the probability of A and B occurring. So really, we're going to use this formula because they're not mutually exclusive. So if I take a look and the probability of A occurring, well, there's going to be 15 possible outcomes. A has 7 of those outcomes, right? 2, 4, 6, 8. Well, there's 7 of them. 2, 4, 6, 8, 10, 12, 14, that's 7. Probability of 3, again, we have 15 possible total outcomes, and the number of outcomes that are event B is, sorry. You know what? I forgot one outcome. I forgot the outcome of 15. So here, the probability of B occurring is 5 out of 15, minus the probability of A and B occurring. Well, there is those elements of 6 and 12, so that happens twice out of 15. So overall, what we get is my probability of A or B occurring is 10 out of 15, or 2 out of 3 if you simplify. All right, example number 2. Now, I apologize that this is in over 2 pages. It just didn't translate well to one. Determine the probability of each of the following events below. Fill in the table of the table, or fill in the table of sums. So really, when we're rolling 2 dice, all of the outcomes will have to be this. So let's just call this dice number 1. And this is dice 2. I'm going to stop the video here, but really, I'm going to fill this in when you return. Really, you're just trying to fill in the sums, right? If you roll a 1 on dice 1 and a 1 on dice 2, a 1 on 1 is 2. So fill out the